All right, so the speed at which the wave travels, electromagnetic wave travels, is 2.998 times 10 to the 8 meters per second. That's given the symbol c. That's the speed of light. Okay. The distance between consecutive crests is, so for each cycle of the disturbance, each repeating cycle, the distance that is the wave travels is called the wavelength. So the crest-to-crest distance or the trough-to-trough distance is lambda. The Greek letter lambda is used to represent wavelength. Okay. The time it takes for the wave to travel a distance lambda is called the period of the wave. So the frequency is the number of cycles that would pass through a given point per second. It's just 1 over the period. Okay. So the speed is the distance traveled divided by the time it takes to travel that distance, and 1 over t is frequency. Frequency is represented by the Greek letter nu. So lambda over t would just be lambda times mu. Okay, so that is the speed of light. So lambda nu is equal to c. Right. So that's in vacuum. So what's the frequency of electromagnetic wave that has a wavelength of 250 nanometers? How would you solve for this? C is lambda nu. So nu is equal to c over lambda. What's the speed of light? 2.998 times 10 to the 8 meters per second. By the way, the speed of light is an exact number. It's defined to be an exact number now. Okay, and it's this definition of the speed of light and the definition of how long a second is that's used to define how long a meter is. Okay. In fact, what's the exact value of the speed of light? Here, 2.9979248 meters per second. That's an exact number. Okay. So when you round that off, make sure you don't round it off too much. You want, let's say, if you have a calculation where your least precise term has only 3 sig figs, then you have to round it up as 2.998. Okay, but if you have more sig figs than that, then you're going to need more sig figs for your calculation for speed of light. Okay. So 2.998 times 10 to the 8 divided by 250 nanometers. That would be 250. What's a nanometer? Nano is 10 to the negative 9. So 250 times 10 to the negative 9 meters. So meters cancel out. Oops, what did I just do? So that gives you how much? It's 10 to the 8 divided by 250 times 10 to the negative 9. Exponential notation, 1.199, so 2 sig figs, 1.2 times 10 to the 50. Okay, so this is 1.2 times 10 to the 15, and the unit is per second or hertz. That's the frequency. Okay. So what's the answer?